All right, we'll continue on with section 3.2. Okay, so we are here doing 3.2. I'm not going to start 3.3. I've got extra days. I've got some buffer days. We have several buffer days, looks like. So I'm just going to cross this off and say, I'll just go up to 3.2. And again, a reminder, 7 to 33 odd is a new assignment. You can skip 1, 2, and 3, and 5, I guess it is, 7 to 33 odd. Okay, so continuing with where we were last time. Okay, problem number 19. F of x equals negative x squared, x plus 1 squared. Okay, so the zeros are 0 and negative 1. They're both considered multiplicity 2. So maybe I'll put that down here, multiplicity 2 for both of them, because there's an x squared, x plus 1 squared, so 0 and a 0. Okay, and then it's either going to go up or it's going to go down. This is actually quite easy. What do you know about x squared? It's always positive unless I plug in 0. What do I know about x plus 1 squared? That's always positive unless I plug in negative 1. So right now, this expression is always positive except for 0 and negative 1. But a minus percent of the whole thing means it's always negative. So this is down, this is down. Okay, so n behavior to the left is down, n behavior to the right is down, and this goes down and back up. Okay. 21, f of x equals x cubed plus x squared minus 2x. So factor out the x squared plus x minus 2, factor some more, x times x minus 1, x plus 2. So the zeros are 0, 1, and negative 2. All right, so x approaches infinity, plug in a million, clearly positive, 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 positive goes that way. When x approaches negative a million, negative a million, negative, 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 3 negatives gives me a negative. Okay. Now we can plug in here and here also, but let's introduce another root that's quite helpful. If we have a 0 of multiplicity 1, the graph will always cut across the x-axis. Okay. Multiplicity 1, the graph will cut across the x-axis. And so what does that mean? Okay. So right now, I have this, right? Each of these is multiplicity 1. There's no square, no cube, no fourth power, and so on. So multiplicity 1 means it cuts across, which means if this is negative, this is automatically positive. So it goes up and comes here. And likewise, at x equals 0, we have multiplicity 1, so it cuts across the x-axis. So this side it's positive, this side it's negative. So that's a nice little shortcut. Put this on your cheat sheet if you want. Okay. If a 0 is multiplicity 1, the graph will cut across the x-axis. So it just goes like this, and like this, and like this. Okay. All right, 31. A little bit unusual. Sketch the graph of a polynomial that has zeros of multiplicity 1 at 1, negative 1, and 2. Okay, so we are 1, negative 1, and 2. And p of x goes to infinity as x goes to infinity. P of x goes to negative infinity as x goes to negative infinity. Whoops. So it goes like so, and it goes like this. Okay, when x goes to infinity, y goes to infinity. When x goes to negative infinity, y goes to negative infinity. It says multiplicity 1, so it cuts across. So this is down, this is up. This is up above the x-axis, this is below the x-axis. Okay, so f of x is any constant. I can have a constant in front, x plus 1, x minus 1, x minus 2, where k is greater than 0. Okay, we could have any coefficient in front also. Okay, and looks like this would be third degree if I multiply this all out. Okay, so the answer to part B is third degree. 33, cubic polynomial means degree is 3. 0 of multiplicity 1 at x equals 2. 0 of multiplicity 2 at x equals 1, and p of negative 1 equals 4, determine p of x and sketch its graph. Okay, so how do I do that? So x equals 2 multiplicity 1, that means I'm going to have an x minus 2. X equals 1 multiplicity 2, that means x minus 1 squared. And if it's a cubic, that's all I got. If I multiply this all out, it's going to be x cubed, right? But I might multiply it by a coefficient, k. So temporarily, I'm going to call it k. How do I find the k? They tell me p of negative 1 is 4. So I plug in negative 1 for x, 4 for y. You say, where's y? Y is p of x. So 4 equals k, negative 1 minus 2, negative 1 minus 1 squared, solve for k. So 4 equals k times negative 3 times negative 2 squared. Let's see, negative 2 squared is 4. So 4 equals negative 12k divided by negative 12. K is negative a third, right? So the polynomial p of x is negative 1/3, x minus 2, x minus 1 squared. And a quick double check. It said the zeros are x equals 2 multiplicity 1. Yes, it is. Exponent is 1. And x equals 1 has multiplicity 2. Correct. And if I plug in negative 1, I get 4. Let's try. If I plug in negative 1, let's see, negative 1 minus 2 is negative 3. That cancels negative 1/3, that gives me 1. And if I plug in negative 1 here, I get negative 2 squared, which is 4. So it's correct. Okay, and let's see, how do I graph it? In behavior, plug in 3. This is always positive. Negative 1/3 is already negative. So negative, negative. These negatives are for the negative 1/3. And x minus 1 squared is always positive unless I plug in 1, which I'm not. Okay, so let's see if I plug in 3, I get positive. So negative times positive is a negative. So this side's going down. Okay, and x equals 2 is multiplicity 1. So automatically it cuts across. It has to go like so. And how about here? Plug in 0. 0 minus 2 is a negative. That's already positive. So negative times positive, positive. So it goes up. So it goes like so. So that's my entire graph for that particular one. Okay. Okay, then some problems like this to give you some graph. And what happens to all of these guys over here? So that's something that we've seen before, especially from the previous chapter, right? Okay, so 23, f of x minus 2. Oh, that picks up the graph and move 2 to the right. Okay, the picture's kind of cluttered here, but the blue is the original f of x. Then the red is f of x minus 2. So I pick up the blue, move it 2 to the right. And then plus 1 means move the whole thing up 1. For 25, for instance. So move the graph number 23 up 1. Okay, so the answer to 23 is the red graph. And the answer to 25 is the green graph. Just move the whole thing up 1. And what happens with 27? F of negative x reflects the graph across the y-axis. Okay, so if you can imagine the original blue graph, and reflect like so. So if you look at the original blue, the reflection across the y-axis looks like that. And then if you look at this part, the reflection would be something like that, f of negative x. Okay, and you should be comfortable with 29. Absolute value of f of x, right? The part that's below the x-axis bounces up above the x-axis, and anything that's above the x-axis stays the same, right? So what you want to do for that one is for part 29, this part here bounces over here. This stays the same, it's above the x-axis. This stays the same, it's above the x-axis. And this one, which is U-shape, give me an upside down U-shape that goes something like this. Okay, I don't want to draw it here to corrupt my book, but you can see the answer in the back of the book if you're stuck on that one. Okay. All right. So that is the end of section 2. So next time we'll begin section 3.3.